Okay guys, remember from this morning, chapter 2-2 continued linear equations. If you remember this morning we talked about linear equations, dependent and independent variables, x and y intercepts, and standard form. Well, let's continue our conversation from this morning by talking about another extremely important topic, slope. Slope is the ratio of vertical change to the horizontal change in a line, or basically it's the steepness of a line. Okay? Steepness of a line. A lot of times people like to think about the roof of their house as having a slope. Okay? The formula for slope is m equals y2 minus y1 over x2 minus x1. And real quickly, the vertical change is the up and down change, or the y-axis change. That would be your rise component. I like to call it rise. The x component, or the horizontal change, is your left and right change, or run. Rise over run. Rise over run. Let's do a problem together real fast. Okay? Slope equals my second y is 10 minus my first y is 4. 10 minus 4 on top. On bottom, my second x is negative 3 minus my first x is 1. Do the math, you get 6 over negative 4, or negative 3 halves. Nice job. Okay, you guys try one right quick. Student example 1. All right, did you get negative 13 over 10? Quickly, that's y2 negative 6 minus y1 7. x2 8 minus negative 2. 8 minus negative 2 means to add. That gives you your 10. Negative 13 over 10. Well, let's get to our first form of a line. And it is called point slope. The point slope form of a line, guys, is a form we can use when we know the slope and a point on the line. The formula for point slope, y minus y1 equals m times x minus x1. I'm now going to highlight all the areas where you'll be plugging in a actual number. Okay? So let's real quickly do that right here in my first little example. Let's write this equation that is in point slope form and standard form. Okay, so what we're going to do is, there's my m, and there will be my x and my y, my x1 and my y1. And all you do, guys, is just plug them in. Y minus y1 is negative 1. So that'll be y plus 1 equals m, that'll be negative 1 half. Negative 1 half times x minus x1 now would be 8. That is point slope. If we wanted to take it, though, from point slope down to standard, it's a real simple process. You just go y plus 1. Go ahead and distribute that negative 1 half. We'll call it negative 1 half x plus 8 halves, or 4. We've almost got it there, guys. If you remember, though, real quickly, standard form is ax plus by equals c. I'm going to skip a couple of steps here, but basically, and I left my x off right there. Basically, what I'm going to do is move my x over here, move my 1 over here. If you subtract 1 from both sides and move the x over, you get y plus 1 half x equals 3. You can't have a fraction in standard form, so we got to change everything. Y'all should be really good at this by now. Multiplying through by that number 2. So over here I'm going to have 2y plus 2 halves x, or 1x. The 2's actually canceled there. And you got to do it on both sides of the equation, is equal to 6. So let me walk you through what we just did. We took it from slope and a point to point slope form, and then we worked it down to standard form. And as we learned yesterday, from here we can graph this line using x and y intercepts from yesterday. All right, student example right here beside us. I'm going to pause and let you guys work real fast. Okay, let's see how you guys did. Student example 2, write the equation of a line passing through these 2 points in standard form. But this time I played a trick on you guys. I played a bad joke, and I'm sorry, but first you got to figure out your slope. This time the slope wasn't given. Look up here at this problem that I worked for you a while ago. This time the slope was given. Since it's not given, it's okay. We just have to find it first, okay? It's no big deal. We know the formula. So first thing I did was roll through here and found the slope of these 2 points, and it's -2, okay? Then I just simply picked a point. I picked 1, 5. It wouldn't have mattered. You could have picked 4, -1. But I chose 1, 5. All the things were positive, and it looked kind of like good round numbers, but it really doesn't matter. Then I done the exact same thing that we did in our first example right here. I took my slope -2, my 0.15, plugged it in, boom, there's my point slope. Then I distributed the 2, moved the x over, moved the constant over, and now all of a sudden you got it in standard form, guys. It's a pretty neat little deal. All right. We finally worked our way down to the granddaddy of them all, slope-intercept form. You guys heard all about this one last year, probably more than you wanted to. Slope-intercept form. Everybody in the world remembers y equals mx plus b. Y equals mx plus b, where m is the y-intercept and m is the slope and b is the y-intercept. M is the slope, b is the y-intercept. We're going to learn to take these 2 points, put them in point-slope form, standard, and then finally slope-intercept form. So please pay very close attention here. Take good notes. We're going to take these 2 points, and we're going to put this line in all 3 forms using all 4 formulas. Notice how I said 3 forms and 4 formulas. That's because we have to also use the first formula we know, slope. So here we go, guys. We're going to take it from here to point slope to standard to y equals mx plus b form. Are you ready? Okay. Let's pick a color. I guess we'll go with blue. Alright. Slope equals y2 is -1 minus y1 is -3. That's minus a -3 over 5. That's my x2 minus x1. And I picked a great problem here because this one works out nicely. -1 plus 3 is 2. 5 minus 4 is 1. So my slope, quite simply, guys, is just a whole number 2. Now, just for future reference, you got to have a rise over run. So in this problem, if we were actually graphing a line here, it would be a rise 2, and we'd put 2 over 1 to have our run component. All right. Now I've got my slope. What's next? You guessed it. We've got to pick a point. It does not matter which point you pick. So just go with the first one you see. And I didn't leave myself a ton of room here, so here we go. I'm going to pick 4, -3. If you choose 5, -1, in fact, why don't you try to choose 5, -1 and see if you get the same thing I get. But I'm going to go through it with 4, -3 and our slope. And we're going to take it, we're going to put it in our point slope form first. Y minus y1 is -3, so that'll be plus 3 equals my slope 2 times x minus x1 is 4. Just do the math now. All I did was distribute. Now from here, this is point slope, right? From here we can go straight to standard. Or if you want to learn how to do it another way, if we subtracted 3 from both sides, look at this. We got it in slope-intercept form. Okay? We got it in slope-intercept form. We could have went from here to standard, but I chose to go to slope-intercept form. From here, and I like to keep a running total here. There's point slope, there's slope-intercept. From here, it wouldn't take any effort whatsoever to get from here to standard. By just moving the 2x over, we got this thing almost in standard form. There are some rules which I will go over with you in class regarding the A, B, and C part of standard form. But mainly, And I got to back out of that because I wrote the wrong sign down. That'd be minus y equals negative 11. Here are the rules that go with standard form. Okay? Here are the rules that go with standard form. When you get your equation in standard form, all three numbers, a, b, and c, are integers. A has to be positive, and both a and b cannot be 0. And I'll go over that with you more in class tomorrow. Oh, let's write them down real fast though. A, B, and C have got to be integers. Okay? A has got to be positive. Having trouble with my pen there, y'all. And both A and B cannot be 0. Both of them can't be 0. One of them can be 0. For instance, I could put 0 in there, and then y would equal 11. I could put 0 in there, and x would equal negative 11 halves. If they're both 0, you've got a false statement, and that can't happen. Okay? All right. While we're on the topic, there are some special slope properties. You will find these special slope properties on page 66. Real simple, but you got to know them. First one we'll talk about is the horizontal line has a slope of 0. All right. A vertical line, or a straight up vertical line, has a slope that is undefined. It's undefined. Think about trying to walk up it. You couldn't walk up a slope of 0, or a slope that's kind of like slope like a wall. You can walk on a slope of 0. You cannot walk on a slope that's directly vertical. So it's undefined. A couple other characteristics of slope. Perpendicular lines, lines that form a 90-degree angle, are negative reciprocals of each other. So in other words, if one of those lines would be 2/3 slope, the other line would have to be negative 3/2 slope. Okay? And then the last special property of lines, parallel lines, real simple. Parallel lines, if those two lines are parallel, then they must have the same slope. So if this one's 1/2, then this one's 1/2, and so on. Okay? All right. Last thing I'm going to go over with you in class, and then I got some problems for you to try tonight and have notes ready for tomorrow. Write an equation of a line that passes through the point 0,4 and is perpendicular to this line right here. Now guys, this right here is where we'll start having a little bit of trouble. Hopefully you'll recall some of this from Algebra 1, but basically this is all we do. Write an equation line that passes through the point 0,4 and it has a slope that is perpendicular to this slope. Well, first of all, you need to know what this slope is. The slope of this line is 3/4. So if this line that goes through 0,4 is going to be perpendicular to y equals 3/4 x plus 2, then the slope of the 0,4 line would have to be negative 4/3. And the rest of the problem is the same as what we did earlier. You take that point and put it in your point slope form. So it's y minus y1 equals m times x minus x1 is 0. Love it when the 0 comes in there. All right, y minus 4 equals negative 4/3 x 4/3 times 0 is 0. You don't have to write plus 0 out here. But if you want to write plus 0, you can, because I'm just fixing to add 4 to it. And we've all of a sudden got this thing solved for y equals mx plus b form. And I'll go over all the details tomorrow, but basically if I was going to graph this line, we would have a y-intercept of 4, it's a slope of negative 4/3, and we're done. Homework assignment for tomorrow. Page 67, 68, 22, 62 even. Go ahead and get started on it tonight, fellas, and great job, and we'll iron out any problems y'all had in class tomorrow. Y'all have a good night.